Our last two sections dealing with decimals will focus on scientific notation. Now, before we focus on scientific notation, I want to focus on multiplying by the power of 10. When we multiply by the power of 10, we're going to move the decimal point to the right, the number of places indicated by the number of zeros that are present. Here's an example. If I'm going to multiply 0.12 times 4,000, I can move the decimal point over 3 places based on the 3 zeros in the 4,000. So I'll move it to the right 3 places. Now 12 times 4 is 48, and because 12 times 4 is 48, we have 0.48, and then we're going to move the decimal point over 3 spaces to the right, turning that 0.48 into 480. When we're dealing with basic math, you can do this mentally. Let's go ahead and focus on the first one. 0.095 times 1,000. Well, we know any number times 1 is the same number. So it's going to be 0.095, and then we're going to move the decimal place over 3 spaces because of the 3 zeros. And that will give us 95. So we move the decimal point over 3 places because of the 3 zeros. Let's look at number 2 and number 3. Number 2, I have 0.31 times 300. Now, what I will have to do, it's not as easy as multiplying by 1, but I still have to multiply. So I can do 0.31 times 3. Well, that is going to be, if I take away my decimal place and just do 31 times 3, I know mentally that can give us 93. I plug in the decimals again because I counted them. I know there's 2 decimal places, so that would be 0.93. But I'm not done because I have to go ahead and figure out what I'm doing with those 2 extra zeros. Because before I went ahead and did 0.31 times 3, okay? And that gave me 93. I put in the 2 decimal places that I counted. Now I'm going to move it to the right 3 places. So if it's 0.93, I move the decimal place over 2 places because the 2 zeros. I'm going to get 93. Okay, let's do it again. This is an easy one. 7.42 times 1. Okay, that's going to give me 7.42. And then I'm now going to move to the right 4 places because of the zeros, because of the 4 zeros. And that will give me 74,200. Okay, I want you to go ahead and do the next 3, 4, 5, and 6 on your own. Go ahead and pause this, check it. Okay, here are the answers. Now number 4 is 1.4 times 20,000. Okay, I know 1.4 has 1 decimal, so I will kind of write that down. I need to place that 1 decimal place, and then I can go ahead and multiply. So 14 times 2 is 28. I add my decimal place, so that's 2.8 because it had 1 decimal place, 2.8. And then now I'm going to go ahead and add the 4 zeros, move the decimal place over 4 places. 2.8, 4 places over will be 28,000. Number 5 is pretty easy. You can just move the decimal place over 1 because of the 1 zero. Okay, 5.9. And then number 6, now the answer is 202.5. And the reason for that is the 4.05 times 5. Now when I divide by a power of 10, I'm going to be moving the decimal point not to the right but to the left. So it's the same thing that we did, but instead we're moving it to the left, the decimal point to the left, based on the number of zeros. And you can see in example 1, the decimal point is moving 2 zeros to the left. Okay, I want you to go ahead and try these 6. Pause the video, and then I'll show you the answers. Please show your work. Don't use a calculator. Okay, here are your answers. As you can see, the decimal point is going to the left. Now we're going to focus on scientific notation. Now scientific notation is dealing with the exponents. This is a number times 10 to the exponent, times 10 to the 1, or times 10 to the 2, or times 10 to the 3. And I'll show you how that looks like in just a little bit. But this is a product. I'm going to be multiplying a number by the power of 10. Here's an example. If I have this large number, 152 million kilometers. Let's write this in scientific notation. I'm going to shorten this, and I'm going to bring the decimal point between the first two numbers. When I bring the decimal point between the first two numbers, I need to count how many places I moved it. Well, I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8 places to get to the 1.5. So I'm counting 8 places. So this is going to be 1.52. And here's the power of 10 times 10 to the 8. Okay, so how many places I move the decimal point will be that superscript, that exponent, that 8. So I moved it 8 places. So on the left I have the standard form, and then when I modify it and I move the decimal point, okay, that's going to be my number between 1 and 10, and then I need to multiply that by the power of 10, and that gives us the complete scientific notation. So the scientific notation is the number between 1 and 10 with the power of 10 and the exponent. Okay, and why do I have 9.62 times 10 to the 5th? That's because I moved the decimal place, okay, over 5 places. Okay, and I did move it to the left. Now let's write the standard form for 3.075 times 10 to the 3rd and 8.04 times 10 to the 4th. Write the standard form. So this is the big number, the larger number. Okay, check your answers to see if you did it correctly. Now sometimes I may ask you for what is the missing number. So if we have 5 times 10 to the question mark, what's that missing exponent? How many places did I move the decimal? I moved it 4 places, so that would be 4. In number 4, what is the question mark? It would be 3.49. Okay, 3.49 times 10 to the 5th power would give me 349,000. Try and bring this back. Do these on your own. Practice these, please. Okay, let's take a look at the next 2 or next 3. Write these in scientific notation. Go ahead, pause the video, and try and do these on your own. Okay, here's the answers. Okay, if you have any questions, please reach out to me. Let me explain this further. Okay, operations in scientific notation. The focus here is when I'm multiplying the powers of 10, I'm going to take those exponents and I'm going to add them. Now the focus here is I have 152.4 times 10 to the 6th power. But that 152.4 should not be a decimal point between the 2 and 4. It should be a decimal point between the 1 and the 5. So I need to move the decimal place over 2 more places. So that's why I'm going to have 1.524 times 10 to the 2. I fixed the 152.4. Now I have the original 10.6 or 10 to the 6th power. And all I'm doing is 10 to the 2nd power times 10 to the 6th power. All I'm really doing here is adding the 2 and the 6. So 10 to the 2nd power times 10 to the 6th power, I would just add the exponents. That's all this is saying. So if I need to modify and fix a number, I'm going to put that in parentheses, focus on that, and then I may have to add exponents. Okay, on the next slide, we're going to be doing the same type of thing. We're adding the exponents. We're going to check the power of 10, okay, to make sure it's power of 10. And then we're going to add and subtract the factors, multiply the sum, okay, or the difference by the common power of 10, and then, if necessary, adjust it in scientific notation. So here we have the exponents, okay. Are the powers of 10 the same? We have 10 and 10, yep, that's the same. The exponents are different, and that's okay. I'm now going to go ahead and add and subtract those. So I'm going to go ahead and look at these three. I'm going to look at the powers of 10. Yes, they're the same. We have one power of 10 and another power of 10. The exponents are different, but that's okay. I'm going to then go ahead and add those exponents. 3 plus 2 gives me the power of 10 with an exponent of 5. Now, if I have 10 to the 6th power, the exponent is 6, plus just 10, that's kind of like saying 10 to the 1 power. Okay, so 6 plus 1 is 7. Okay, so the powers of 10 are the same. 3 plus 6 is 9. Okay, what about this? Let's add and subtract. Let's do these 4. I'm going to go ahead and have you pause it, and let's see if we can do this correctly. Okay, here's the answers. The first one here, okay, I'm going to add 2.871 to 4.52, and that's going to yield 7.391. Now, because I'm adding, okay, the exponents are going to stay the same. Now, only if I was multiplying 10 to the 6 times 10 to the 6, okay, would I change or add those exponents? But if you can see, I have parentheses plus parentheses. So because I'm adding, the exponents will stay the same. So in the same way, number 5, okay, I'm going to subtract 5.34 minus 1.294. I'm going to change those numbers, but the exponents will stay the same. Okay, 7.95 plus 4.632. That number changes, but I can, because I'm just adding here, the exponents will stay times 10 to the 8th. But the problem here is I have 12.582 times 10 to the 8th. I can move the decimal point 1 to the left, and that will modify my exponent 10 to the 9th. Okay, let's do the last one. 9.482 minus 3.492. I'm going to subtract, and my powers of 10 and exponents stay the same. Okay, so I hope this makes a little bit more sense as we did the practice problems. Now, when I multiply numbers in scientific notation, I can use the commutative and associative properties. Now, on the last slide, on the previous slide, we were adding parentheses, but here I'm going to be multiplying outside of the parentheses, okay? So I can use the commutative or the associative. Remember, associative uses those parentheses. I'm going to multiply the number factors. I will then multiply the powers of 10 by adding the exponents because I'm multiplying the parentheses. And then I'm going to convert the answer to the proper scientific notation if necessary, very similar to what was on the last practice problem. Okay, here's some examples. Okay, if I multiply 1.2 times 10 to the 4th power times, see I have the parentheses, 3.4 times 10 to the 3rd power. Okay, so what I have to first do is multiply 1.2 times 3.4. And what I did was I took those and I put them in a separate parenthesis. Now, you don't have to put them in the separate parentheses if you're understanding that I have to multiply those numbers first. So 1.2 times 3.4 is going to be 4.08. I have that done. Now I need to focus on my exponents. My exponents, because I'm multiplying these, I'll go ahead and add 4 plus 3. And that's going to be to the 7th, 10 to the 7th power. And here are two other practice problems with the answers.